What is inductor saturation in electrical DC-DC converter design? Have you ever wondered what happens when an inductor in a DC-DC converter reaches its limits? Today, we will discuss inductor saturation and its impact on electrical design. Inductor saturation is a critical concept in power electronics, especially when designing efficient power systems and renewable energy applications. Inductor saturation occurs when the magnetic core of the inductor reaches its maximum magnetic flux density. At this point, the core can no longer increase its magnetic field in response to rising current. When saturation happens, the magnetic domains inside the core become fully aligned. This alignment means the core loses its ability to store additional magnetic energy. Consequently, the inductance value drops significantly, which affects how the inductor limits current changes in the circuit. In the context of DC-DC converter design, inductors play a vital role. They store and transfer energy efficiently. When an inductor saturates, its inductance can decrease abruptly or gradually. This change leads to higher current ripple, increased core losses, and potential instability in the converter's operation. A key parameter to understand is the saturation current, which is the maximum direct current an inductor can handle before its inductance drops by a certain percentage. This percentage usually ranges from 20 to 35%. The saturation current rating depends on factors like the core material, geometry, and temperature. For example, ferrite cores typically exhibit hard saturation, where inductance collapses sharply once saturation is reached. On the other hand, powder cores show soft saturation, which offers a more gradual decline in inductance. This characteristic provides more design flexibility. When designing a DC-DC converter, engineers must select inductors with a saturation current rating that is higher than the expected peak current. This practice helps avoid saturation and ensures stable operation. Additionally, designers consider core material, size, and temperature effects to maintain inductance within the desired range under all operating conditions. In summary, inductor saturation in DC-DC converters occurs when the magnetic core can no longer support an increase in magnetic flux. This situation causes a drop in inductance and impacts converter performance. Proper inductor selection and design are essential to avoid saturation and maintain efficient power conversion. Understanding this concept is key for anyone involved in electrical engineering, especially in the fields of power systems and renewable energy.